Welcome back, everybody. Last video we talked about the dimensioning rules, and this video we're gonna learn more about the rule for applying nodes on a drawing. And if you look at this slides here, and some of the notes here, and the legend. And this legend here, all the drawing must have a legend. And when you have a drawing, you want to make sure that calling out some of the notes, detail notes connected with a leader line. So for example, you want to call out this note's chamfer, and if you have a threaded area, you're going to call it out and call it as a threaded area, and you have to let the manufacturer know that what kind of shape this is, and you're going to call it out as a diamond roll. And then this is the example that has a poor placement of detail notes, and you don't want to put the text in the area where you have a lot of line in conflicts with your text or overlapping. This case is not going to give you a good presentation. And these are the acceptable placement of a detail notes when there's a space. If you have a space, then you can put them inside. But if you don't have a space where you have a lot of line, I would just put it outside and call it outside. And do not dimension to hidden line or center line of the hidden line. So don't dimension center line of the hole, and any dimension, any hidden line, don't dimension them, and you will just call out the diameter of that hole. So superimposing a node is poor practice. So again, the drawing should have legend, general notes, and your legend abbreviation are explained in the legend. So some of the legends is things like ASSY, assembly, FAO, finish all over. Some of the notes, this is a proper punctuation of notes is very important. So power, brush, or surfaces, and some of this note intending for clarity. You want to make your notes a little bit more clear to the manufacturer, and you're going to say, hey, all dimension and conditions shall be field checked and verified by the proper trade or the contractor, and the size of the general note should be 0.25 inches high, and all fillet and round should be about 0.12 diameter. This kind of a letter should be about between 0.125 to 0.18 in height. And some of this spacing between line of the same note should be spacing between the same notes should be 0.06, and the spacing between separate notes should be 0.125. Number of word per line limited per, very important, because if it's the number of the word, don't make it too long, otherwise it's gonna create some confusion to the manufacturer. Line in note should be approximately equal, so the line in note should be approximately equal. So part family, and if you look at these two example here, and part family is when you have a group of such parts in the same family. For example, this example here, this figure here, two parts from the same family. They contain the example of two parts from the same family. These parts were placed in the same family based on design characteristic. They have exactly the same shape and size. However, you will note that the difference in the area of production processes If you look at the production processes, the material is different, the tolerance difference, finish the way they want to finish it, they want to paint it, whereas this, they don't want to paint it, they want to sand and buff it. For this, the figure here contains example of two parts from the same family, because although the design characteristic of these two parts are dramatically different, they're not the different in size, shape. A close examination will reveal that they are similar in the area of production processes. Part 1 is made of stainless steel. Its dimension must be held to a tolerance of plus or minus 0.002, and 3 holes must be drilled through it. So you got 3 holes. Same thing, you have to do the same characteristic except just the shape of it, but they have to drill 3 holes as well. Same material, same tolerance, and so on and so forth. So even though the different size and shape, they have exactly the same manufacturing characteristic. So grouping technology and similar parts are grouped together in part, group, or family according to design characteristic, manufacturing processes requirement. Technology is due to the development in manufacturing resulting from automation and computerization. Grouping technology, grouping part into family. There are 3 methods that can be used for grouping part into family: site inspection, round sheet inspection, part classification, and coding. Site inspection is the simplest, least sophisticated method. It involves looking at parts, photo, part, drawing of the part, and this inspector basically he look at the photo, look at the drawing, and through such examination, um, the inspector, very experienced personnel, can identify similar characteristics and group them accordingly. So the second method involves inspection, the routing sheet used to route the part through a various operation to be performed. So we're gonna have to provide the inspector with the ability to create inspection routing sheet so they can efficiently plan their inspection. There can be effective way to group part into manufacturing part family, provide the routing sheet are correct. So the routing sheet that you guys gonna provide with some kind of specification, and where the inspector or the experienced personnel is gonna look at the specification and put them into in a group. And the most widely used method for grouping part is the method which is part classification and coding. This is also the most sophisticated, most difficult, and most time-consuming method. Part classification and coding is complex enough to require more in-depth treatment than the other 2 methods. So all 3 methods are require the expertise of experienced manufacturer personnel. And part classification. So we have let's go over here. We talk about site inspection, routing sheet inspection, part classification, and coding. So part classification and coding. Part classification and coding is a method in which the various design or the manufacturing characteristics of the part are identified, listed, and assigned a code number. Recall that these characteristics are referred to as attributes. This is a general approach used in classify and coding part. So from here, you can see the part classification and coding is the most sophisticated method. And here, they want to talk about part classification and coding. They have a design attribute, manufacturer attribute, and combined attribute. So what is this design attribute group? Design, you can see we're going to go from design attribute group, classification and coding system that use design attribute as the qualified criteria fall into this group. Commonly used design attribute include dimension, tolerance, shape, finish, and material. So they want to group them based on the design attribute, things like dimension, tolerance, shape, finished material. Manufacturer attribute group classification and coding system that use manufacturing attribute as a qualifying criteria fall into this group. Commonly used manufacturing attribute include production processes, operational sequence, production time, tool require, fixture require, patch sizes, all that, anything that associated with manufacturer attribute code group, then they're going to group them into together. Combined attribute is there's an advantage in using design attribute, and advantages in using manufacturing attribute. System that fall into design attribute are particular advantages if the goal is design retrieval. Symbol part classification and coding system. Here we talk about the symbol part classification and coding group. Some companies develop their own part classification and coding system, but this can be an expensive and time-consuming approach. The most widely used approach is to purchase a commercially prepared system. Rather than you have to prepare it by yourself, you would just purchase a commercially prepared system. So this part classification and coding is to basically how we're going to group a certain product together based on their shape, their finish, the material, and so on and so forth. And this is how exactly we talk about how we're going to group this two different entity. And again, to repeat that example here, so this problem here, part 1, and you can see this contains the example of two parts, and from the same family, this part will place in the same family based on design characteristic. They have exactly the same shape and size. However, you notice that the difference in area of production processes, things like you can see they use a different material, they use different tolerances, and different kind of finish. This is to paint, this is not to paint. But for this figure here, you can see it's different shape, but they have the same characteristic because they have the same material here, same tolerance, and 3 hole. They're gonna drill 3 hole, and here they do the same thing, drill 3 holes. Even though it's not the same shape, and they consider they have the same manufacturing characteristic. So let's go to the advantages and disadvantages of that. So the advantages is you can see this advantages improve design, enhanced standardization, reduce material handling, simplify production scheduling, improve quality control, and they have a disadvantages of improving quality control. So we talk about the improved design. Group technology allow designers to use their time more efficiently and productivity by addressing the amount of new design work required each time a part is to be designed. Enhanced standardization, as you have already seen, some factor account for part of the enhanced standardization. Setup and tooling also become more standardized because similar part require similar setup and similar tooling. With that, you can save a lot of time because you have the same kind of setup, same kind of tooling. You don't have to, change it to a different tool when you work on a different object. This is why the grouping technology is, they have a lot of advantages. Reduce material handling. A functional arrangement causes excessive movement of the part from machine to machine and back. Specialized work cell reduce such movement to minimize and in turn reduce material handling. If you not the same group and use this material and then you have to change the different material, this could create some wasting some of the material. So again, this is a good advantage to reduce some of the material handling if you group them with a grouping technology. Simplify production scheduling with machine group into specialized work cell and arrangement of part into family. There's less work center scheduling requiring less scheduling. Overall, group technology involves less sophisticated scheduling. And the last one is to improve quality control. This does two things, both of which tend to improve the quality of parts. It promotes pride in the work among employees assigned to each work cell. It makes production error and problem easier to trace to specific source. In transitional manufacturing shop, each work center performs certain tests, but no one center is responsible for an entire part. Such an approach does not promote quality control. So in spite of these advantages, there are several disadvantages associated with a group technology. Transitioning from machine in a transitional shop into a specialized work cell can cause a major disruption. Such disruption translates quickly into non-monetary losses. As a consequence, some managers are reluctant to pursue group technology. Another problem with group technology is that part classification coding is a time-consuming, difficult, and expensive process, especially in the initial stage. This causes some manager to back at the expense. So, because they have to, because the time is so consuming to go from one group to another group, and the best way to do is sometimes not to do the grouping. So after all these advantages, I would recommend to produce your stuff in grouping. Even civil engineering, we done some of the project in a grouping. So for example, I have 3 different projects. I have Safe Route to School, Cycle 8, Cycle 9, and State Street Park. And these 3 projects happen to be in the same kind of the same design and the same vicinity. For example, State Street Park, they build a park and they're going to build some bike lane and pedestrian walking sidewalk, and is continue from State Street Park to Safe Route to School, Cycle 8, Cycle 9. So that means when you put them combined together, bid them out as one bid, get one contractor on board, and to build this kind of work at the same time, and it's going to be very cost effective and can save a lot of effort instead of getting 2-3 contractors building 3 different projects and doing the same work. So with that, we're gonna summarize this chapter, and to summarize it, and I'm gonna go to the next video to summarize this chapter.